Hello and welcome to video lecture number 15, which covers section 1.9, day 2, inverse functions. By the end of this lesson, you will be able to determine whether a function has an inverse function graphically, and you will also be able to write the equation of the inverse of a given function. Please take a moment to read the descriptions of horizontal line test and one-to-one functions, and write down any questions you have and be prepared to ask them tomorrow. So I would like you to draw this diagram which shows what a one-to-one function will look like. So notice on the left we have a domain, and those x values get mapped to certain y values. Notice what's happening. Each x goes to exactly one y, and there isn't two different x's going to a single y. So since every y is unique and is only used once, this is what we call one-to-one. Some examples of functions that are one-to-one would be the linear function, f of x equals mx plus b, the rational parent function, 1 over x, and the square root parent function, square root of x. Because all of these graphs would pass the horizontal line test, meaning they are one-to-one, their inverses will be functions. So if a function is not one-to-one, then it is many-to-one. And so if you look at the diagram, notice we have two different x's going to the same y value. This is still a function, but because the same y value is being used with two different x's, we call that many-to-one, and this would fail the horizontal line test. So below the diagram, here are two common examples of many-to-one functions. That would be the quadratic parent and the absolute value parent. Notice, unless we restrict the domain, since these graphs will fail the horizontal line test, their inverses will not be functions. Example 1 gives you a series of functions graphically and asks you to determine if their inverses would be functions. If you say no, then you must restrict the domain so it would have an inverse. So take a look at example 1b. Notice that if I run a horizontal line across this graph, I can touch it in more than one spot. Since this function fails the horizontal line test, it's many-to-one, therefore its inverse will not be a function. However, if we restrict the domain and only look at a segment of this graph, and that segment I will shade here, this would pass the horizontal line test. So let's restrict the domain to what I've shown you here. So if we restrict the domain to approximately, looks like negative 1.5 to positive 1.5, this particular function then would have an inverse function. So looking at the function in example 1d, any horizontal line that I run across the graph will only intersect it in one spot. So that means it passes the horizontal line test. Since it passes the horizontal line test, this is a one-to-one function. Therefore, its inverse is a function. Please try example 1a and c on your own and have those ready to check for tomorrow. Part 2 of this lesson focuses on objective number 2, which is being able to write an inverse function given a function. Please take a moment to look over the steps in the process involved in finding and writing an inverse function. This will be the series of steps in order that we will use every single time when finding an inverse function. In example 2, we're asked to write the inverse functions of the given functions and also find the domain of the inverse that we write. So following step 1 from the information above, I've replaced f of x with y. Since the domains and ranges are switched in an inverse function, we will switch the variables x and y in the equation. Now we will solve for y using algebra, and when we're done, we have found the inverse function. The first move in isolating y is to subtract 5 from both sides. The final step in isolating y would be to get rid of the exponent of 2, and we do that by square rooting both sides of the equation. So the last step we will need to take is simply to replace y with f of -1, the symbol for the inverse, just to remind ourselves that what we have just found is the inverse function. Now, we are asked to write the domain, and if you remember, the definition of inverse functions reads that the domains and ranges are switched. So the range of the original function, which was y is greater than or equal to 5, has now become our domain of the inverse. And you might be able to tell that just by looking at the inverse function, because it's a square root. We cannot have square roots of negatives, therefore the domain must be all numbers greater than or equal to 5. So we'll write that in interval notation, and now we're complete. So going back to yesterday's lesson, if I graph both the original function, and I'll highlight that in red, x squared plus 5, and I graph the inverse function we just found in black, notice what we see. Their graphs are reflections about the line y equals x, and points on the red graph, their coordinates are flipped around with the points on the black graph. So that is just confirmation that we have indeed found the correct inverse. So example 2b is a little more challenging because it's a rational function, meaning there is a fraction involved, and there is a x variable in both numerator and denominator. So I've went ahead and shown you the first two steps, which really aren't complicated. I've replaced f of x with y, and then we switch the positions of x and y, and since there were two x's in the original, both of those now become y variables. The next step in solving any equation that has a denominator is to get rid of that denominator. Therefore, I've multiplied both sides of the equation by y minus 2. Doing so on the right side essentially cancels the denominator out, so we're only left with y plus 3 on the right side. The next step in the solving process requires us to distribute that x into the parentheses. Now remember, the goal in this process is to get the y by itself, so it would be in our best interest to get these terms x, y, and y next to each other on the same side. So I will subtract y from both sides and move the negative 2x over as well. So after adding 2x to both sides and subtracting y from both sides, I'm left with xy minus y equals 2x plus 3. Notice that the two terms next to each other on the left both have a y, so now I will factor that y out. So once the y has been factored out from xy minus y, the last move is to get rid of the x minus 1. It's being multiplied by y, so to get rid of it on the left side, I will divide both sides by x minus 1. That will cancel out the x minus 1 on the left, and will give us 2x plus 3 divided by x minus 1 on the right. So take a breath. After a series of several steps, we've reached the inverse function. Now we must find its domain. Remember, the domain of the inverse is the range of the original. They've been switched around. So the range of the original was that y could not equal 1. So the domain of this function would be x cannot equal 1, but we will write that in interval notation as negative infinity to 1 union with 1 to infinity. Please take a moment to pause the video and try example 2c and 2d and have them ready to check for tomorrow. This concludes video lecture number 15. As always, please take a moment to look over the problems I've done with you, as well as the problems you've done on your own, and write down at least one question you still have after watching this video lecture. Thanks again for watching, and good luck.